So just to recap, I'm Johan Blumhardt, sales engineer for WatchGuard for the Northwest. I cover everything from Colorado on up to Alaska. As you have probably been aware, we've been focusing this series, so this is the third one in a series of traffic management. So just to recap, let's go ahead and bring up the recap screen. Traffic Management 101 was about these new features available in 11.9. For instance, I can go ahead and limit all users on the trusted interface, allowing maybe 2 megabits per second maximum and 1 megabit per second upload, guaranteeing certain amounts of traffic available bandwidth for individual users, setting a maximum or guarantee. Really where this is helpful, and many of you are aware of my background. I spent 14 years in public education. When we talk about public education, it's a very complex environment. So this would be perfect, for instance, limiting your guest Wi-Fi users, your students, so they're not taking up all of your bandwidth from you. From there, we went to Traffic Management 102. So to review what 102, we covered application control. So with application control, it used to be that we could only allow or deny certain types of applications through the WatchGuard. As you might remember, there's about 1,800, actually last time I counted it, it was considerably higher, but 1,800 plus different applications. So again, if you want people to be able to get to Facebook but not play games on Facebook, maybe for some marketing or user acceptable agreement, we can do that through application control. Another one that we can block certainly is BitTorrent. Now, part of the other component to that is that security, being able to stop, for instance, those bad protocols or bad applications from getting outside your network, bypass proxies, etc. Now, with Traffic Management 103, what we're going to focus on today is using quality of service, or more known, widely known as QoS. It's primarily an IP concept where data traffic on a network, either a LAN, so a local area network, or a WAN, wide area network, is subject to scrutiny and control. Now with this, obviously, if you look at a network, you ultimately have 3 different environments that QoS could take a participate in. You have your internal network, maybe it's your network is a large enterprise, you have switches that you're running QoS on, and then at the very border, let's say you have WatchGuard, now we're running QoS on the WatchGuard, and then we have QoS on the WAN side as well. The WAN side obviously just needs to ensure that your ISP is aware of those packet headers and knows how to handle those. So layer 3 IP packets can carry either IP precedence, known as IPP value, or a differentiated services code point value, otherwise known as DSCP. So with WatchGuard, we're able to support IP precedence as well as DSCP. Now, quality of service supports either as a RFC compliance, either because DSCP values are backward compatible with IPP. So the advantage of a DSCP is that you have more layers to define. For each level in IPP, you can have 3 sub-levels. Now, for the sake of today's demonstration and discussion, we're going to focus solely on IPP because that's going to be sufficient for most networks out there. So as you may recall, the series kind of, these webinars, we start out with a slideshow, and then we go into more of a hands-on approach and talk about how that can impact your, how you can use that, in this case, quality of service to improve your networks. So why would you use or usage of QoS? So when you talk about your network, maybe you bandwidth necessary for a critical application or service is variable or unknown. Now, 2 of the biggest ones that I can think of right off the top of my head are VoIP and video services. Now, these are critical services that are extremely sensitive to jitter. So typically, someone might create a VLAN specifically for these types of traffic. However, you can actually take that in some of these smaller environments and simply apply QoS to those services that mix with the traditional data. On the WatchGuard side, we can assign QoS markings per interface or per policy. Now we'll go over why you would choose to do per interface or per policy. Now a tip on this, I actually came across this as I was working through things in my lab, because I went ahead and throttled down my WatchGuard so that it thought my network was considerably slower than what it was. And as I was monitoring through Service Watch, I recognized that it kept saying reconnecting, reconnecting, reconnecting. So my monitoring tools were having problems communicating with my firewall. Well, I went in and set up quality of service for that policy, and I'll show you how to do that. And all of a sudden, now we have uninterrupted access to that management interface. As I mentioned, today we'll focus on IPP QoS. As we look at the different priorities, there are a number of these tables that you see here readily available on the internet, but as a general rule of thumb, as we start to talk about QoS, everything is essentially going to be at a priority of 0. Now, the higher the priority you go, the more sensitive it is on your network, and the faster your devices are going to process those. So for instance, if it was a priority 7, it's going to process those packets over a priority 0. So again, just to clarify, everything is, once we set up quality of service within our networks, everything's running at a 0 unless we go ahead and increase that priority, and we'll show you how to do that today. So again, just to recap, we've gone through some of these steps with traffic management 101 and 102, but just to recap, because a lot of people aren't going to know how to properly use quality of service or traffic management, we just go ahead from WatchGuard and uncheck, or the default is that traffic management and quality of service features are not enabled by default. So to enable them, you just go to Setup, Global Settings. The Global Settings dialog box will appear. Select the Networking tab, and then just choose a check mark, Enable all traffic management and quality of service features that you see here. Click OK. Now that is a required step before you configure any traffic management or any quality of service features on WatchGuard. Now again, to use some of the newer services that we're talking about with application control, limiting it to maybe 2 megabits or 10% for Pandora, we want to make sure that the OS compatibility is 11.9 or higher. We can simply do that with Setup, OS Compatibility, 11.9. Now, just as a side note, I oftentimes hear from people that maybe they're still on E-Series or some of the legacy devices. Is there a way that we can go ahead and upgrade that configuration? Absolutely. If you send me an email, I will go ahead and send you step-by-step instructions on how to export those configuration policy and import that into a newer device. You can actually go back and forth between some of our devices very easily with WatchGuard. So as we look at the quality of service interface configuration, why we would choose to set up quality of service on an interface rather than a policy. One of the reasons why we would choose to just globally assign the interfaces, if all traffic from that interface were to be assigned QoS marking. Now let's say you have a WatchGuard and you have port 4 that goes into maybe your VoIP system or goes into a switch, and your VoIP system's all as a separate network that's not VLAN, but a separate physical network, then we can simply assign QoS based on the interface. Maybe it's also that you have a guest Wi-Fi that is on, let's say, port 3. Well, then we can just go ahead and go to the network interface. We can select the marking type on there. So again, for today's demonstration, we're going to go ahead and choose marking type IP precedence. Now, under marking method, we have several different values. We can choose preserve, so we're not going to change the value. We're going to assign a new value, or we're going to clear the bit value. Now, if you have, let's say, switches that are assigning QoS at the switch level, maybe it's a switch port that's assigning it, we just want to go ahead and preserve that. We could also say, well, let's assign it, which we're going to do today, or let's go ahead and clear it. Maybe our ISP, for whatever reason, doesn't want us to send those QoS markings upstream. We can go ahead and clear that as needed. So again, to assign, we're going to go to policy. So now we're talking about the policy, individual policies. So as we look at WatchGuard, and we'll go into this as in our hands-on, we're going to look at that policy, and we're going to go advanced quality of service. We're going to select the marking type. So again, today we're doing IP precedence. We're going to choose to assign a marking. We're going to choose a value and prioritize traffic based on that QoS marking. And then obviously the big component to see whether or not our actions are taking effect and how that affects traffic, we're going to look at the traffic, monitor that traffic through the Firebox System Manager and specifically through the Service Watch. So at this point, I'll go switch over to my live environment. So what I have running here is a VMware workstation that's going through a virtual XTM on here. We also have Dimension. So it's a nice way to have a test lab environment. Some of you, if you're resellers, you might want to look at or think about having an environment like this where I can change anything and I can see the impact of those changes. So just to recap, we went to Setup, Global Settings, Networking, Checkbox, or enable the check to enable all traffic management and quality of service features. That's the first step. Then we check the OS compatibility. So again, just to verify we are 11.9 or higher. So from there, we went into, I went ahead and slowed down my network considerably so that what I do has more extreme impact. So as you look at this, we have, I set a speed limit on interface 1 of 1,500 kilobits per second on here. And I'm going to go ahead and say IP precedence preserve, and I'm going to prioritize traffic based on that quality of service marking. So that's kind of the overhead view. Now, as I mentioned, I was doing some testing in here, and all of a sudden I saw this could not connect, trouble connecting between my Firebox System Manager, specifically with Service Watch, to my firewall. So I had trouble connecting, so I said, well, gosh, let's go ahead and, under this WatchGuard management rule, let's assign QoS markings for that, which I would encourage a lot of you, most of you to do in your networks. For whatever reason, let's say you had a network flood, the number one reason or thing that you need to be able to do is reach your switches as well as your firewall. So as we look at, for instance, the quality of service, as we can see here, we're going to override per interface setting. So regardless of what interface this is going in or out at, we're going to assign it, again, IP precedence, IPP, assign, and we're going to choose the highest level. Now, whether it's a 6 or a 7, that's kind of the industry standards between your network traffic. So again, with WatchGuard, I'm going to assign that as my highest level because regardless of any traffic that's going through my network, I need to be able to get to my WatchGuard and be able to manage it. And I'm going to say QoS marking. Now, custom value allows you to put your value here, but we're just going to select QoS marking. And that resolved all of my issues with reconnecting through these tests. So the other thing that I did, step 2, was this DNS proxy. As many of you are aware, DNS is a very critical protocol with network traffic. So one of the first things users are going to do, launch a browser, and let's say they try to get to Google, it needs to resolve that IP address. So again, extremely critical on what's going on in the network. Now, in terms of how that traffic relates to other traffic, typically it's about a 2. And I can send you that table, which is also available in our help documents as well. So again, I'm going to assign this rather than just a 0, which would be normal traffic. I'm going to go ahead and elevate that slightly for DNS so that anyone can look up DNS requests. Now, in this case, we're going to use FTP as sort of the bad guy, the traffic hog on my network. So as I look at quality of service, I just have the basic, and again, if you recall, everything's going to basically be running at the 0 value if I don't have any value assigned to that. So again, this is just running at 0, and then my proxies are going to be the traffic that I want to get through. So again, my HTTP and HTTPS, because we have, again, so many websites going to that HTTPS model. In fact, if you look at our newer models, I'm not sure if you read the release, but we have the M400 and M500 brand new on the market right now that are, the speeds are through the roof. They're using the Quick Assist Intel technology to be able to handle that decryption, encryption on the fly a lot better. So going back to the HTTP proxy, as we look at, for instance, QoS, overriding per interface settings, we see here we're, again, choosing IPP, assign it. Now, rather than just leave it at that 0 level, we're going to give it a higher priority. Now, I would encourage you, as you look at your networks, to kind of outline those services that you have. Maybe it's VoIP, maybe it's video, life-size video, what have you. And then from there, maybe it's also print jobs. Kind of get an overview of that, what's going on in your network, and then start to fine-tune some of these values. And then if you find that you don't have enough, your scale between 0 through 7 isn't really enough to handle it, then you could look at a DSCP that gives you more flexibility within those, the QoS. So again, your HTTPS, just go ahead and make sure that that's addressed as well. Override per interface settings, value 2. Now, I can't tell you how many times I go out, I work with different people on their firewalls, and they have still the default outgoing rule that they're running everything through. Again, from a security standpoint, you want to make sure that that firewall is locked down so that, let's say you have a computer on the network that somehow maybe someone plugs in a jump drive, infects it, and is trying to send out spam. You don't want that firewall to allow spam out from that computer, and certainly you want to be able to report on it through Dimension, get that proactive notifications, maybe an email to yourself to say, hey, this computer's doing weird behavior on your network. Let's go ahead and check it out. So again, remove that default outgoing policy. Now, where people get into trouble is that they start getting into proxies, but then they forget maybe something like a DNS proxy, which is quite necessary, as I mentioned earlier, because without DNS, your users aren't going to be able to do any address resolution. So now, moving forward with this, let's go ahead and start a download. Again, we can see some of our traffic here. I have went to Service Watch. Now, if you haven't noticed, with Service Watch, we could simply right-click and choose Settings and choose the services that we want to monitor. So for this, I went ahead and chose a custom scale, which is 1,500 kilobits per second, which is what I set that interface speed to. Now from there, I chose to select the HTTP proxy, HTTPS proxy, FTP, and DNS. So as we look at this, we can see live data or our traffic as it's coming through. Again, Dimension's a wonderful tool to be able to do historical reporting, but on the fly, I'd love to use Firebox System Manager, number of tools in here as well that you can leverage. So I'm going to go ahead and click on a file that's 61 megs on here. It's going to start that FTP process. We see FTP is rising through the roof there. Now I'm going to go ahead and start a new session, and let's say I want to go to view ESPN. As we know, Seattle Seahawks corporates based in Seattle, so again, very strong Seahawks fan base at corporate. But let's look at what this is doing now to our traffic. So as I start that traffic, the first one's buffered through. We can see that dropping off. Now, as it's coming through the video's loading, we can actually see how the FTP has dropped down to 181, and ultimately HTTPS proxy has full reign to take all the traffic that it wants in that network. Now, I actually have, this is a VMware, as I mentioned, and I'm kind of overloading it with the RAM is requiring, so it's kind of seems like it's buffered up a little bit. But we can see that impact where the HTTP proxy, it was at 0, all of a sudden we took it, and now it's taking all the bandwidth that it needs. Now we can apply that to, there it comes back again. We can apply that to all sorts of avenues or network traffic within the network. Maybe it's a VoIP traffic, maybe it's video. So again, we can see real clearly now how our FTP proxy just dropped down. It's still using some, but it's giving all priority to the HTTP proxy. And again, that's not much traffic for some of this high-def video out there. But you can easily see how that impacts that live traffic. So at this point, I wanted to wrap up, but did want to encourage you to keep your eye out for that link that we'll send out for the YouTube recording, as well as if you have any topics that you would like to see in the future covered in these FireBite sessions. Again, it's just meant to be kind of a quick snippet of information that you can hop in, hop out, and hopefully glean something to help you be a WatchGuard system administrator. So hopefully these sessions are helpful for you. And again, if you have any questions or you want to go ahead and have any suggestions, I'll throw out my email address here real quick, and you can go ahead and email me, and we'll take your suggestions for future sessions.